I want to be honest with you about what physics says about death, because the honest account is more interesting and in some ways more consoling than either the religious account or the dismissive materialist account, and it is almost never told with the precision it deserves. The dismissive materialist account says, you are a collection of atoms governed by the laws of physics, and when those atoms stop functioning in the organized way that constitutes a living body, there is nothing left of you. You cease to exist. End of story. This account is not wrong exactly, but it is incomplete in a specific and important way. It focuses on the cessation of biological function and ignores what the physics of time and information implies about the permanence of the past. The religious account, in its many versions across human cultures, says there is something beyond the physics, a soul or consciousness that survives bodily death, that persists in some form after the body dies. I am not going to argue against this, because the arguments against it are well rehearsed and not the point of this video. The point is that physics itself, taken seriously to its conclusions, has something specific and non-trivial to say about death that neither the dismissive materialist account nor the religious account captures. I want to develop 3 different perspectives that physics provides on death, and I want to develop each of them with the precision they deserve, because the imprecision of popular accounts diminishes the genuine insight. The first perspective is the block universe. This is the most important, because it addresses the deepest question: is the past real? Is it true that the moments of your life, once lived, simply cease to exist? Physics says no. The past is permanent. The events of your life are inscribed in the 4-dimensional structure of space-time and cannot be erased. The second perspective is the conservation of atoms and information. The physical substance of your body, the atoms, is conserved. The information about how those atoms were organized, the specific pattern that constitutes your body and brain, is in principle encoded in the physical state of the world after your death, though in a highly dispersed and inaccessible form. The laws of physics do not erase information. The third perspective is quantum mechanics. The many worlds interpretation has specific implications for what death means from the first-person perspective that are both fascinating and deeply contested. I will describe the argument and its limitations honestly. None of these perspectives provides what the religious account promises: ongoing conscious experience after death, a continuation of the first-person perspective. I want to be clear about that from the beginning. Physics does not provide evidence for the survival of consciousness after the death of the brain. What physics provides is something different, and I think genuinely significant: the permanent reality of your existence in the structure of the universe. Let me begin with the block universe, because it is the foundation on which everything else rests, and because it is the most directly relevant to the question of what death means. The block universe follows from the relativity of simultaneity, which I derived in the block universe video from the 2 postulates of special relativity. Different observers in relative motion disagree about which events are simultaneous. There is no universal present moment. The only consistent ontological position is that all events at all space-time coordinates are equally real, past, present, and future alike. The 4-dimensional space-time manifold with all its events, from the Big Bang to the far future, is the complete and static description of physical reality. This has a specific implication for the question of whether the past is real. In the block universe, the past is as real as the present. An event that occurred 1 billion years ago exists at its space-time coordinates in the block, just as real as the event of your reading these words right now, just as real as events that have not yet occurred from your perspective. The past does not cease to exist when time moves past it. It simply is, permanently and immutably, at its space-time coordinates. Now apply this to the events of your life. You were born. That birth event, the space-time coordinates of your entry into the world, is in the block. It is there permanently. Every moment of your childhood, every experience of growing up, every perception, every thought, every action, all of these events are in the block at their space-time coordinates. They do not cease to exist as they become part of your past. They remain permanently at the coordinates where they occurred. The moment you are living right now is in the block. It will always be in the block. Your experience of reading these words is a permanent feature of the four-dimensional structure of the universe. Nothing can change that. The past is permanent. And the future moments of your life, including the moment of your death, are also in the block at their space-time coordinates. They exist already in the sense that the block contains them, even though from your perspective they have not yet occurred. Your death event is in the block. It is a specific location in the four-dimensional space-time manifold, and it exists there right now waiting for your world line to reach it. What happens at the death event? From the block universe perspective, the answer is precise. The death event is the last coordinate on your world line. Your world line, the four-dimensional curve that traces your path through the block, terminates at the death event. After that coordinate, there is no further extension of your world line. The world line simply ends. But the world line does not disappear when it ends. The entire world line, from birth to death, is a static geometric object in the block. It exists in the block as a complete curve, with its beginning at the birth event and its ending at the death event, and every event of your life at the appropriate coordinates along the curve. The world line is permanent. It is in the block, all of it, from the moment of your birth to the moment of your death. In this sense, death is the end of your traversal of the block, the end of the ongoing process of your world line advancing through space-time, but it is not the end of your presence in the block. Your life is permanently inscribed in the block as a world line from birth to death. Nothing, not even the heat death of the universe, can retroactively remove the events of your life from the block. They are there at their coordinates forever. Let me develop the contrast between two senses of the word end. In the first sense, death ends your subjective experience. The ongoing process of consciousness, the continuous first-person experience of being you, the moment-to-moment traversal of your world line terminates at the death event. The neurons stop processing. The organized information processing that constitutes your thoughts and perceptions ceases. There is no further coordinate on your world line where you are having a subjective experience. In this sense, death is the end. In the second sense, death does not end your existence in the block. Your world line continues to exist in the block permanently at the coordinates it always occupied. The events of your life continue to be real features of the block. The fact that you existed, that you experienced, that you acted and thought and loved and suffered, all of this is permanently inscribed in the four-dimensional structure of space-time. In this sense, death is not the end. These two senses are not in contradiction. They are two different questions with two different answers. The first asks, will your subjective experience continue after death? Physics says no. The second asks, will the events of your life remain real after your death? Physics says yes, permanently and irrevocably. The second answer is not nothing. It is, in fact, one of the most profound implications of modern physics for the human condition. The past is permanent. Your life is in the past of all future moments. The events of your life will always have been. And the will always have been is not a consolation prize. It is a genuine feature of the physical universe, confirmed by every experiment that tests special relativity. The physicist Max Tegmark puts this as, you will have always existed. That phrase, will have always existed, in the future perfect tense captures exactly what the block universe says about the permanence of your life. It is not that you will exist after death. It is that the fact of your existence will always be a fact at every future moment. It will be true that you existed, experienced, and were a world line in the block, ready to change how you see the world. The relationship between the physics of time, the block universe, and what death means for the permanence of your experience is one of the deepest themes in the 12 principles I have assembled for understanding the fabric of reality. Get your copy of 12 Principles for Understanding the Fabric of Reality at realityprinciples.com. Let me now describe the specific physics of what happens to your body at and after death. Because the physical narrative is both more interesting and more beautiful than the common account, and because it connects the abstract physics of conservation laws to the concrete reality of what happens to the atoms that temporarily constitute you. Your body contains approximately 7,000 trillion atoms, that is the number 7 followed by 27 zeros, written as 7 times 10 to the power of 27. The specific breakdown, roughly 60% are hydrogen atoms, about 26% are oxygen, about 11% are carbon, with the remaining few percent being nitrogen, phosphorus, calcium, and smaller amounts of many other elements. Every one of these atoms was forged in a star. The hydrogen atoms are among the oldest in the universe. They were produced in Big Bang nucleosynthesis in the first few minutes after the Big Bang, approximately 13.8 billion years ago. The heavier elements, the carbon, oxygen, nitrogen, calcium, were synthesized in the cores of massive stars and dispersed into space when those stars exploded as supernovae. The calcium in your bones, the iron in your hemoglobin, the phosphorus in your DNA, all of these were manufactured in the nuclear furnaces of stellar interiors that predated the formation of our solar system. These atoms are ancient. They have been in nebulae, in stellar cores, in planetary surfaces, in the oceans, in other organisms. Every atom in your body has a 4 billion year history of participation in the physical world before it became part of you. And when you die, each of these atoms will continue to participate in the physical world with billions of years of future history ahead of it. The conservation laws that govern these atoms are among the most precisely tested statements in all of science. Mass energy is conserved. The total mass and energy of the atoms is the same after your death as before. Electric charge is conserved. The total charge of your atoms is unchanged. Baryon number is conserved. The number of protons and neutrons in your atoms is the same. These conservation laws hold with a precision measured in parts per 10 to the 27th in some cases. When you die, the atoms do not disappear. What changes is their organization, the specific way they are arranged and interacting. The living body is an extraordinarily organized arrangement of atoms maintained by a continuous input of free energy from food and oxygen. The organization is the product of billions of years of evolution, the specific molecular machinery of cellular metabolism, the precise architecture of the nervous system, the intricate regulatory networks that keep the body functioning. This organization is what makes you alive, and its maintenance requires constant work. At death, the work stops. The atoms are no longer maintained in their organized configuration. The second law of thermodynamics takes over, driving the system toward higher entropy, toward more probable, less organized configurations. The atoms disperse. The first stage is autolysis. The cell's own digestive enzymes, released when the lysosomes rupture without the energy to maintain membrane integrity, begin digesting the cellular contents. Proteins are broken into amino acids. Lipids are broken into fatty acids and glycerol. DNA is broken into nucleotides. The organized molecular machinery of the cell is disassembled. The second stage is putrefaction. Bacteria, both from the gastrointestinal tract, which is never sterile, and from the environment, proliferate in the nutrient-rich environment of the decomposing body. These bacteria further break down organic molecules, producing gases including carbon dioxide, hydrogen sulfide, methane, and ammonia, as well as simpler organic compounds. The third stage is skeletonization. In most conditions, the soft tissues are fully degraded, leaving only the mineral matrix of the bones. Bone consists primarily of hydroxyapatite, a crystalline form of calcium phosphate, along with collagen. The collagen degrades over decades to centuries. The mineral matrix persists for much longer. Bones have been recovered from Neanderthal burials 100,000 years old. Over geological timescales, even the bone mineral is dissolved and recycled. The calcium enters the soil water and is taken up by plant roots. The phosphorus is incorporated into plant proteins. The carbon dioxide released by decomposition enters the atmosphere and is fixed by photosynthesis into new plant matter. Over millions of years, the atoms may be incorporated into sedimentary rock, subducted into the mantle, melted in magma, and erupted through volcanoes, returning to the surface. The iron may be weathered from rock and dissolved in rainwater, carried to the ocean, incorporated into the iron-binding proteins of marine organisms, and deposited on the ocean floor in sediments. The carbon may be buried as organic matter, transformed under pressure and heat into coal or petroleum, and eventually burned to return as carbon dioxide. The atoms cycle continuously through every form of matter that the Earth produces. They were in stars before the Earth formed. They will be in stars again when the sun expands into a red giant and swallows the inner solar system, vaporizing the Earth and dispersing its atoms into the solar wind. They will drift through interstellar space and perhaps be incorporated into a new planetary system forming around a distant star. Your atoms are not yours. They never were. They were borrowed from the universe for the duration of your life and will be returned to continue their journey through the physical world for billions of years after your death. The atoms that constitute you right now have been in stars, in nebulae, in the ocean, in other organisms. Every carbon atom in your DNA was once in the body of another living being, perhaps many other living beings, before it became part of you. And after you die, it will be part of many more. This physical continuity does not constitute personal identity. The atoms do not carry your memories, your personality, or your consciousness with them when they disperse. They carry mass, charge, and quantum numbers. The pattern that constitutes you, the specific organization of the atoms, does not persist after death, even though the atoms do. But the atom's continuation is a genuine form of physical continuity, connecting you to the physical world in a way that extends far beyond your biological lifetime. This is the physical continuity that remains after the biological continuity of your life ends. Your atoms were never yours alone, and they never will be. They are borrowed from the universe for the duration of your life and returned when you die. Let me now turn to the question of consciousness and what physics says about it, because it is the most directly relevant question for what death means to you as an experiencing entity. Consciousness is, in a specific sense, the central puzzle of the entire question of death. When we ask whether death is the end, what we are really asking is the end of my biological existence also the end of my subjective experience? Is there anything it is like to be me after I die? And this question is entirely about consciousness, about whether the first-person perspective, the felt experience of being, can survive the death of the physical system that currently instantiates it. The relationship between the physics of the brain and subjective experience of consciousness is one of the deepest unsolved problems in philosophy and science. The philosopher David Chalmers named it the hard problem of consciousness in 1995, distinguishing it from the easy problems. The easy problems of consciousness, though none of them are actually easy, include explaining how the brain integrates information, how it controls behavior, how it processes sensory data, and produces appropriate responses. These are difficult scientific questions, but they are questions about the mechanism of cognition, how specific physical processes produce specific functional behaviors. They are hard, but not in principle impossible to answer with physics and neuroscience. The hard problem is different. It asks, why does the physical processing of information in the brain produce any subjective experience at all? Why is there something it is like to see red, to feel pain, to hear music? Why does the electrochemical processing in the visual cortex not occur in the dark without any accompanying inner experience? Why is there an inner life at all? Physics and neuroscience can describe the neural correlates of consciousness, the specific patterns of brain activity that correspond to specific experiences. We can measure which brain regions activate when you see red, which patterns of neural firing correspond to the experience of pain, which specific circuits are engaged when you hear music. But describing the neural correlate of an experience is not the same as explaining why that neural activity is accompanied by a subjective experience. The gap between the physical description and the felt experience is the hard problem. The hard problem has no accepted solution. There are several main positions. Physicalism says consciousness is entirely a physical phenomenon produced by the organized information processing of the brain. On this view, there is no additional ingredient beyond the physics. Consciousness is what the physical processing feels like from the inside. It is the intrinsic character of certain types of information processing. When those physical processes stop at death, consciousness stops. Dualism says consciousness involves a non-physical element, a mind or soul, that interacts with the physical brain but is not reducible to it. On this view, consciousness could in principle survive the death of the physical brain because it is not dependent on the brain in the way that purely physical properties are. But dualism faces severe problems. How does a non-physical mind interact with a physical brain? And what is the non-physical element made of? Panpsychism says consciousness is a fundamental feature of reality, present in some form in all physical systems, not just brains. On this view, consciousness does not emerge from non-conscious physical processes. It is present at the fundamental level. The consciousness of a brain is a highly organized form of a more fundamental property that exists in simpler forms in all matter. Illusionism says the hard problem is based on a mistake. The felt quality of experience, the redness of red, the painfulness of pain is not what it seems. Our introspective access to our own mental states is unreliable, and the appearance of a hard problem is itself a cognitive illusion produced by the very mental processes we are trying to understand. Each of these positions has serious philosophical difficulties. The hard problem remains genuinely open, and this openness matters for the question of death. We cannot say with certainty what happens to consciousness when the brain stops, because we do not have a theory of consciousness that we are confident is correct. What physics can say is what is consistent with what we know. The specific pattern of organized physical processes in the brain, the specific connectivity of neurons, the specific patterns of synaptic weights, the specific electrochemical dynamics is what currently instantiates your consciousness on any view of consciousness that takes the physical substrate seriously. When the neurons die and the organization is destroyed, the specific physical basis for your current form of consciousness is gone. Even if consciousness is a fundamental feature of matter in some broader sense, the specific form of consciousness that is you with your particular memories, personality, and subjective experience depends on the specific organization of your brain. This is not an argument for or against any specific theory of consciousness. It is a statement that whatever consciousness is, its specific instantiation in your case depends on the physical organization of your brain. When that organization ceases, that specific instantiation ceases, what, if anything, persists beyond that cessation is the question that physics cannot currently answer. The physicist Roger Penrose has proposed that consciousness involves quantum processes in the microtubules of neurons, the orchestrated objective reduction hypothesis developed with the anesthesiologist Stuart Hameroff. On this view, consciousness involves quantum coherence in the neuronal microtubules with wave function collapse events that are not described by standard quantum mechanics, but involve a new physics at the intersection of quantum mechanics and general relativity. If Penrose and Hameroff are correct, consciousness involves physics beyond the standard model, and the question of what happens to consciousness at death depends on the details of that new physics. This is speculative. The evidence for quantum coherence playing a functional role in neural processing is not compelling, but it illustrates that the question of consciousness and death may involve physics we do not yet have. What mainstream physics says, however, is that the brain is a physical system subject to the laws of physics as we currently understand them: quantum mechanics, thermodynamics, electromagnetism, and general relativity. The organized electrochemical dynamics of the neural network are governed by these laws. When the neural organization is destroyed at death, the specific physical basis for the organized information processing that constitutes your consciousness ceases. The first-person experience, the subjective continuity that makes you you from moment to moment, ends. The question of whether there is something it is like to be a dispersed collection of atoms, whether the carbon atoms that were in your brain continue to contribute to some diffuse form of panpsychist consciousness after they have been incorporated into the soil or atmosphere, is not answerable by current physics. But it is not the continuation of your specific form of consciousness. Whatever panpsychist consciousness might be present in the atoms after death, it would not have your memories, your identity, or your experience. The conclusion I want to draw carefully and honestly is, physics does not support the survival of personal consciousness after death, in the specific sense of the continuation of your first-person perspective and your subjective experiences. The physical basis for that consciousness is the organized neural network of your brain. And when that organization ceases, the specific form of consciousness it instantiates ceases. This is the best current assessment, not a dogmatic pronouncement. And this is where the block universe becomes essential. The cessation of your conscious experience at death does not erase the fact that you were conscious. The moments of your conscious experience are in the block. They were real. They remain real as permanent features of the space-time structure of the universe. The subjective experience of your life, every moment of awareness, every perception, every felt experience, is permanently inscribed in the block at the space-time coordinates where those experiences occurred. The 12 principles in my book address exactly this: how the physics of information, time, and the structure of the universe relates to the deepest questions about consciousness and death. Ready to change how you see the world? Get 12 principles for understanding the fabric of reality at realityprinciples.com. Let me now describe what quantum mechanics says about identity and continuity, because it reveals something important about what you are and therefore what your death means. In quantum mechanics, particles are not individually distinguishable. Two electrons are not just very similar, they are identical in the strict quantum mechanical sense. They are excitations of the electron quantum field, and the field does not label its excitations. There is no sense in which you can identify electron A and track it through a series of interactions as the same electron A. You can track quantum numbers, charge, spin, momentum, but not individual identity. This quantum mechanical indistinguishability of fundamental particles has an implication for the question of what you are. If you are ultimately a collection of fundamental particles, and if those particles are not individually identifiable, then your identity cannot be the identity of specific particles. Your identity must be something else. The pattern, the organization, the specific way the particles are arranged and interacting. This is confirmed by biology. The atoms in your body are continuously replaced. Red blood cells are replaced every 4 months. The lining of your intestine is replaced every few days. Proteins in your brain are replaced over months to years. By the time you are a few years old, most of the atoms that constituted your body at birth have been replaced. The person you are now is made of almost entirely different atoms than the person you were 5 years ago. But you feel like the same person. Your memories connect to the past self. Your personality persists. Your sense of identity is continuous. This continuity cannot be a continuity of atoms. The atoms have changed. It must be a continuity of pattern, the specific organization of the atoms, the specific connectivity of the neural network, the specific memories encoded in the synaptic weights. This is the ship of Theseus realized in flesh. If you replace every plank of a ship, is it the same ship? If you replace every atom of your body, are you the same person? The philosophical tradition says identity is continuity of pattern, not continuity of substance. Your identity persists through atomic replacement because the pattern, the neural connectivity, the memories, the personality is preserved even as the atoms change. What death destroys is not the atoms but the pattern. The pattern, the specific neural connectivity that constitutes your identity, is the physical basis of the continuous self that you experience. At death, the pattern is not preserved. The neurons die and their connectivity is lost. The specific organization that constituted your identity does not persist in any physical system after death, but in the block universe, the pattern existed. It was real. It occupied space-time coordinates. And the block universe preserves the reality of those coordinates permanently. The pattern that constituted you existed at specific space-time coordinates, the coordinates of your life. In the block, those coordinates are permanent. The pattern is permanently inscribed in the structure of space-time at the coordinates where it existed. This is a different sense of persistence from the usual one. We usually think of persistence as continuation through time, the same object existing at different times. In the block universe, persistence is presence in the block. The pattern exists at the space-time coordinates of your life permanently and immutably. It does not continue after your death in the sense of existing at later coordinates. But it also does not cease to exist. It remains at the coordinates where it existed. This distinction between continuing existence and permanent presence in the block is the key to understanding what physics says about death. Your life does not continue after death, but your life is permanent in the block. The pattern that was you is in the block. It will always be in the block. And that is a genuine form of persistence, not the persistence of continuation, but the persistence of the permanent past. Let me now describe the thermodynamics of biological life and death more completely, because it connects the question of death to some of the deepest themes in physics: entropy, free energy, the arrow of time, and the relationship between life and the second law. Life is a thermodynamic process. At the most fundamental level, a living organism is a physical system that maintains a local decrease in entropy at the cost of increasing the entropy of its environment. A living human body maintains an extraordinarily organized state, the specific arrangement of trillions of cells, each with its specific molecular machinery, each operating within the precise biochemical conditions required for function, in a world that thermodynamics says should be driving inexorably toward disorder. How does the body maintain this organized state? By consuming free energy. Every calorie you eat is free energy, energy in a form that can do thermodynamic work, reducing entropy locally. Your body uses this free energy to maintain its organization, to repair damaged proteins, to pump ions across cell membranes, to generate the electrochemical gradients that drive neural signaling, to synthesize new molecules to replace those that degrade. The total entropy of the universe increases as you consume free energy, but your local entropy stays low, maintained against the thermodynamic tendency toward disorder. Life, in this view, is a temporary and local reversal of the second law, a region of the universe where entropy is decreasing, sustained by the consumption of free energy from an external source. The free energy ultimately comes from sunlight. Photons from the sun carry low entropy electromagnetic energy that drives photosynthesis, producing organic molecules with low entropy that are then consumed by animals, including humans, up the food chain. The second law is not being violated. The total entropy of the sun plus the earth plus the energy radiated away to space is increasing. But locally, in the organized structure of a living body, entropy is decreasing. The living body is an entropy-consuming, order-maintaining island in a sea of increasing entropy. Death is the end of this process. When the organism dies, the free energy input ceases, the mechanisms that maintain the organized state against thermodynamic dissipation stop working. The second law reasserts itself unconstrained, and the organized structure of the living body is progressively disassembled. The low entropy organization of the living body is replaced by the high entropy disorder of decomposed organic matter and dispersed atoms. From the thermodynamic perspective, life is a process, and death is the end of the process. The atoms before death and after death are the same atoms, subject to the same thermodynamic laws. What changes is the organization, the specific way the atoms are arranged, which was maintained by the free energy input during life and is no longer maintained after death. Erwin Schrödinger, in his 1944 book, What is Life?, described life as a system that feeds on negative entropy, that consumes order from its environment to maintain its own order. He called the ordered information content of an organism its negentropic contribution. Life, in Schrödinger's view, is the physical process by which thermodynamic order is temporarily concentrated and maintained. When the process stops at death, the order is dissipated. But the thermodynamic laws that govern the dissipation do not erase the history of the order. The second law drives systems toward higher entropy, but it does not retroactively erase the organized states that existed before the entropy increased. The low entropy state of your living body is a feature of the block at the space-time coordinates of your life. The higher entropy state of the dispersed atoms after death is a feature of the block at later coordinates. Both are real. Neither erases the other. The physical laws are time reversible at the microscopic level. If you could exactly reverse the velocities and quantum states of all the atoms after your death, the laws of physics would drive them to reconstruct the organized state of your living body. The information about the organized state is encoded in the microstate of the atoms, their positions, momenta, and quantum states. In principle, that information is still there, encoded, in the dispersed system, accessible to a sufficiently capable physical agent. This is not practical. The quantum coherence of the microscopic state is irreversibly lost through decoherence in a time far shorter than any biological process. The second law holds in practice, but the logical possibility of reconstruction, the fact that the laws of physics are information preserving at the microscopic level, is a statement about what death is and is not at the most fundamental level, physics. Death is not the physical destruction of information. It is the thermodynamic dissipation of the organized pattern that constitutes your identity into a dispersed, inaccessible form. The information is still there, encoded in the positions and momenta of atoms spread across the environment. But it is inaccessible, and no physical process will reconcentrate it into the organized pattern that was you. And in the block universe, the organized pattern, your life, exists permanently at its space-time coordinates, regardless of what happens to the atoms after death. The The block preserves not the current state of the atoms, but the complete four-dimensional history of all the atoms, including the organized history that constitutes your life. The block is not the atoms as they are now. The block is the complete space-time record of how the atoms were at every moment. And that record is permanent. That is the fullest statement of what physics says about death. The atoms are conserved. The information about the organized state is in principle preserved in the physical state of the world, though inaccessibly dispersed. The organized pattern that constituted your identity is permanent in the block at the space-time coordinates of your life. And the subjective experience, whatever consciousness is, ceases when the physical basis for it is destroyed. Physics provides three things about death. It provides conservation, the atoms continue. It provides permanence, the block preserves the history. And it provides honesty, the subjective experience ends. All three are true, and all three are grounded in the best tested physics we have. Let me now describe what quantum mechanics says about identity and continuity, because it raises questions about what you are in a way that is relevant to the question of what your death means. In quantum mechanics, particles are not individually distinguishable. Two electrons are not just very similar, they are identical. There is no sense in which you can point to electron A and electron B and say this electron is the same one I saw earlier. Electrons are excitations of the electron quantum field, and excitations of a quantum field are not individually tracked. They exist as patterns in the field, not as distinct individuals. This has an implication for the question of what you are. The atoms in your body are not the same atoms that were in your body a few years ago. Your body replaces most of its atoms over a period of months to years through metabolism and cellular renewal. The specific atoms that constitute your brain at any moment are different from the atoms that constituted it when you were born. The physical continuity of your identity is not the continuity of the atoms. It is the continuity of the pattern, the specific organization of the atoms. This is the ship of Theseus problem for biological organisms. If you replace every plank of a ship, is it the same ship? If you replace every atom of your body, are you the same person? The continuity of personal identity seems to be a continuity of pattern rather than a continuity of substance. What this implies for death is that death is the end of the pattern, not the end of the atoms. The pattern, the specific organization of neurons, the specific memory traces, the specific network of synaptic connections is destroyed when the neurons die. The atoms continue, but the pattern is gone. From the block universe perspective, however, the pattern exists permanently at the space-time coordinates where it existed. The pattern of your brain, the specific physical organization that constitutes your identity, is a feature of the block at the coordinates corresponding to your life. It does not cease to exist when you die. It simply has no coordinates in the block after the death event. This is a subtle but important point. The pattern of your brain, which is the physical substrate of your identity, is a permanent feature of the block at the space-time coordinates where it existed. Your identity, whatever physical pattern that amounts to, is permanently inscribed in the structure of space-time. It cannot be erased. Whether this provides any consolation depends on what you mean by consolation. If what you want is for your subjective experience to continue after death, for there to be ongoing first-person experience, the block universe does not provide that. The subjective experience has no further space-time coordinates after the death event. But if what you want is a sense that your life mattered in the physical structure of the universe, that the events of your life are real and permanent, the block universe provides exactly that. Your life is permanently inscribed in the four-dimensional structure of space-time. Every moment you have experienced, every perception and thought and action is a permanent feature of the block. Nothing can remove them. They are there at their coordinates forever. Let me now describe the thermodynamics of biological life and death, because it connects the question of death to some of the deepest themes in physics: entropy, the second law of thermodynamics, and the arrow of time. Life is a thermodynamic process. A living organism maintains a low entropy internal state, the highly organized structure of a functioning body, by consuming high quality energy from its environment and producing low quality, high entropy energy in the form of heat. Life is sustained by an ongoing flow of free energy from sunlight through photosynthesis and the food chain that maintains the low entropy organization of living tissue against the constant thermodynamic tendency toward disorder. The second law of thermodynamics says that the entropy of a closed system tends to increase. An organism is not a closed system. It continuously exchanges matter and energy with its environment. By doing so, it maintains its own low entropy at the cost of increasing the entropy of the environment. The total entropy of the organism plus the environment increases, consistent with the second law. But the organism locally maintains its low entropy organization by continuously using free energy. Death is the end of this thermodynamic process. When the organism dies, it can no longer maintain its low entropy organization. The free energy input ceases. The organizing processes stop. The second law reasserts itself, and the highly organized structure of the living body is progressively disassembled. Entropy increases. The organized complexity of life is replaced by the disordered simplicity of decomposed organic matter. From this perspective, life is a temporary and local reversal of the second law, a region of decreasing entropy sustained by the consumption of free energy. Death is the end of this temporary reversal and the return to the thermodynamically expected state of high entropy. But this thermodynamic picture, while accurate, does not capture everything that is true about life and death. It describes the average behavior of the atoms. It does not describe the specific history of this particular collection of atoms, the specific pattern that constitutes you, the specific experiences you have had, the specific way your atoms were organized to produce your consciousness. The thermodynamic description is a statistical description. It averages over the specific details of the microstate and describes only the macrostate, temperature, pressure, entropy. The specific history of your atoms is contained in the microstate, and the microstate is not captured by the thermodynamic description. The laws of physics at the microscopic level are time reversible. Every microscopic process that occurs has a time-reversed version that is also allowed by the laws of physics. The atoms in a glass of water, if their positions and velocities could be reversed simultaneously, would reassemble into a piece of ice. The atoms of a dead organism, if their positions and momenta could be reversed simultaneously, would reassemble into a living organism. Of course, this reversal does not happen spontaneously. The probability of the random thermal fluctuations of a macroscopic system producing the precise microstate required for this reversal is so small that it is effectively impossible on any time scale shorter than the age of the universe, raised to enormous powers. The second law holds in practice because the number of high entropy microstates is overwhelmingly larger than the number of low entropy microstates. But the logical possibility of the reversal is a statement about the nature of the laws of physics. They do not erase information. The information about the organized state of the organism, the information about the specific microstate of the living body, is not destroyed by death. It is encoded in the final microstate of the system, the specific positions and momenta of all the atoms as the organism decomposes. In principle, this information could be used to reconstruct the original organized state. This is not consolation in any practical sense. The reconstruction is not happening. But it is a statement about the physics. Death does not destroy information at the microscopic level. The laws of physics are information preserving. The specific physical state that constituted your living body is encoded in the final state of the atoms even after they have dispersed into the environment. The 12 principles in my book are organized around exactly this kind of precision, what physics actually implies about the deep questions of existence, death, and the permanence of the past, as opposed to what the popular accounts claim it implies. Ready to change how you see the world? Get 12 principles for understanding the fabric of reality at realityprinciples.com. Let me now address what the many worlds interpretation of quantum mechanics says about death, because it raises the most dramatic and most counterintuitive implication of quantum mechanics for the question of personal identity and survival. The many worlds interpretation, proposed by Hugh Everett III in his 1957 Princeton PhD thesis and championed by David Deutsch, says that the wave function of the universe never collapses. The Schrödinger equation applies universally and always. When a quantum measurement with two possible outcomes occurs, the universe branches into two copies, one for each outcome. Both branches are equally real components of the universal wave function. The observer in each branch observes a definite outcome, unaware of the other branch. Most quantum measurements in everyday life have no direct relevance to personal identity. The outcome of a quantum event in a distant laboratory does not affect whether you live or die. But there is a class of quantum events where the connection is direct. Events where one outcome involves the death of the observer and another outcome involves the observer's survival. The quantum suicide argument and the related quantum immortality argument were discussed by Hans Moravec in 1987 and formalized by Bruno Markel in 1988. Max Tegmark gave the most detailed recent analysis. The argument, stated simply, is this. In the many worlds interpretation, every quantum event produces branches for all possible outcomes. For any event with a non-zero probability that you survive, there exists a branch in which you survive. The probability weight of that branch may be small, vanishingly small, after many such events, but the branch exists. From the first-person perspective, you always find yourself in a branch where you survived, because in all branches where you did not survive, there is no first-person perspective to observe anything. The selection effect is total. Consciousness is only present in branches where the observer is alive. Applied to death, every moment, quantum fluctuations in your body could, in principle, with astronomically small probability, prevent every cause of death. A quantum fluctuation could reverse the progression of a fatal disease. A cosmic ray could cause a quantum effect that prevents the blood clot. A chemical fluctuation in the brain could delay the neurological cascade of dying. These events are not prevented by the laws of physics, they are merely fantastically improbable. In the many worlds interpretation, the branches corresponding to these improbable but possible events exist. In those branches, you are still alive. And from your first-person perspective, you can only ever find yourself in a branch where you are alive. Therefore, from your first-person perspective, you are immortal. You will always find yourself in the branch where you survived, however improbable that branch has become. This is the quantum immortality argument. It is genuinely thought-provoking, but it has serious problems that I want to state honestly. The first problem is the measure problem. The many worlds interpretation assigns each branch a probability weight, the square of the amplitude of the wave function component corresponding to that branch. The branches where you survive each near-death event have exponentially smaller probability weight than the branches where you die. The many worlds interpretation does not say you should ignore the probability weight and focus only on the existence of the surviving branch. Most physicists who accept the many worlds interpretation accept the Born rule as a rational guide to expectation. If you take the born rule seriously in the many worlds context, then even though the branches where you are extremely old exist, their probability weight is so small that they make a negligible contribution to the average expectation for how old you will be. The rational expectation for your lifespan, even in the many worlds interpretation, is approximately the same as in the Copenhagen interpretation. You will likely die around the statistically expected age. The second problem is the definition of personal identity across branches. In the many worlds interpretation, after any quantum event, the world branches into two copies of everything, including you. Which branch is the real continuation of you? The many worlds interpretation does not privilege any branch. Both are equally real, equally continuous with the pre-branching you. There is no fact about which branch you are in after branching. Both copies are equally you, equally continuous with the pre-branching observer. This makes the quantum immortality argument ambiguous. Even if there is always a branch where the observer survived, it is not clear that the observer who survived is the same person as the observer who would have died in the other branch. They both started as the same person, but after the branching, they are separate observers with separate experiences. The survival of one branch is not the survival of a single continuous self. The third problem is empirical. People die. If the quantum immortality argument were a significant effect, if observers experience a selection effect toward the long-lived branches, we would expect to see individuals living to extraordinary ages that are inconsistent with standard biology and mortality rates. The oldest confirmed human on record lived to 122 years. The distribution of maximum lifespans is consistent with standard biology. There is no evidence of the selection effect that quantum immortality would produce. Despite these problems, the many worlds interpretation does make one statement about death that is interesting and perhaps consoling. The branch where you died is not the only branch. There is always a branch, however small in probability weight, where you are still alive. The universe in the many worlds sense, the full wave function of the universe contains branches in which you continue to exist even after branches that look from the outside like your death. This is not immortality in any meaningful sense, but it is a consequence of the many worlds interpretation that is worth understanding precisely because it illustrates how radical the implications of taking quantum mechanics seriously can be. The honest summary of what quantum mechanics says about death is the standard quantum mechanical description of the brain as a physical system governed by quantum mechanics implies that the organized physical state of the brain is destroyed at death, ending the specific form of consciousness it instantiated. The many worlds interpretation does not change this in any practically significant way. What it adds is the existence of branches of exponentially small probability weight in which the specific cause of death did not occur. Let me now return to the block universe and close with what I think is the most important and most honest account of what physics says about the meaning of death. You are a world line in the four-dimensional space-time block. The world line begins at your birth event and ends at your death event. Between these events, the world line traces a path through the block, accumulating proper time as it goes. The world line is a complete geometric object in the block. It does not come into existence progressively as you live. The block contains the entire world line simultaneously. The birth event is in the block. The death event is in the block. Every event of your life is in the block at its appropriate space-time coordinate. When you die, the world line ends. There are no further coordinates. Your subjective experience has no location in the block after the death event. The ongoing process of consciousness, the continuous first-person experience of being you, terminates. This is the end, in the sense that matters most to the experiencing self. But the world line, the complete set of events that constitutes your life, is permanent. The block does not change. The events at the early coordinates of your world line remain as real after your death as they were during your life. The experiences, perceptions, thoughts, and actions that constitute your life are permanent features of the four-dimensional structure of space-time. What kind of permanence is this? It is the permanence of the past, the specific, irreversible way in which the past is fixed. The present is malleable. Your choices and actions determine what happens at the next moment of your world line. The future is open. The specific events at your future coordinates are not yet determined, or at least not determinable from your current position. But the past is fixed. The events at earlier coordinates on your world line cannot be changed. They cannot be erased. They are there permanently. And in the block universe, permanently means permanently not just for your lifetime, not just for the lifetime of the Earth, not just for the lifetime of the universe, but in the complete timeless sense that the block encompasses. The block is not a thing that exists in time. It is the totality of space-time, all of it at once. The events at the space-time coordinates of your life are features of this totality. They are not features of the past in the sense of something that is past. They are features of the block in the sense of something that is timelessly. This is what the philosopher Thomas Nagel might call the view from nowhere, the objective view outside time that sees all events at all coordinates as equally real. From this view, the events of your life are as real as any events in the universe at any time. They are in the block, they are real, they are permanent. Whether this permanence matters to you, whether it provides any comfort when confronting the reality of your own death, depends on what you value. If what you value is the continuation of your subjective experience, the felt ongoing awareness of being you, then the permanence of the block does not provide what you value. The subjective experience ends, but if what you value includes the reality of your life, the fact that the experiences, relationships, actions, and moments of your life were real, that they happened, that they mattered in the physical structure of the universe, then the block universe provides something genuine. Your life was real. It is permanent. It is inscribed in the four-dimensional structure of space-time with the same permanence as the events of the Big Bang. The philosopher Bernard Williams wrote about the tedium of immortality, the idea that an immortal existence would eventually become unbearable, that the prospect of endless continuation would be a burden rather than a gift. Whether or not you agree with Williams's argument, his point illuminates something about what we actually value in our lives. Not endless duration, but the reality and meaning of specific moments. The block universe says those specific moments, the ones that made your life worth living, the ones of greatest joy and depth and connection, are permanent. They are in the block. They will always have been. And the future of a universe that contains those moments is different from the future of a universe that does not, in the specific sense that the block of the universe with your life in it is a different block from the universe without your life. You made a difference. The block that contains your life is a different block from the block that would have existed without you. The events of your life affected subsequent events, and those events affected later events, and so on through the causal chain of the block. Your existence, your presence in the block is permanent and causal. It is part of the permanent structure of the universe. Death does not undo this. Death is the end of your world line, the last coordinate on your path through the block. It does not remove the earlier coordinates. It does not remove the effects of your earlier events on later events. It does not remove your presence from the block. You will have always existed. This is the most precise statement physics can make about death. And it is, I think, the most honest and the most profound. What happens when you die? Your subjective experience ends. Your atoms continue their journey through the physical world, cycling through the Earth systems and eventually through the stars. Your identity, the pattern that constituted yourself, is gone from the present moment, but permanently inscribed in the block at the space-time coordinates of your life. The universe, in the four-dimensional sense that physics describes, contains your life permanently. It always will. That is not nothing. It is not everything. But it is real, grounded in the best physics we have, and more than the dismissive materialist account acknowledges. Death is the end of your world line. It is not the end of you in the block. And you will have always been in the block for as long as the block is what it is, which, in the timeless sense of the block universe, is forever. The many worlds interpretation says that every quantum measurement branches the universe into multiple copies, one for each possible outcome. There is no wave function collapse. The Schrödinger equation applies universally and always. When a quantum measurement with two possible outcomes occurs, the universe branches into two copies, one in which the first outcome occurred, one in which the second occurred. Both branches are equally real. Most quantum measurements in everyday life have no direct relevance to personal identity. But there is a class of quantum events that, in the many worlds interpretation, has specific implications for survival. Events where one outcome involves the death of the observer and another outcome involves the observer's survival. The quantum immortality argument, associated with Hans Moravec and Bruno Marchal and discussed by Max Tegmark, goes like this. In the many worlds interpretation, every time there is a quantum event with a non-zero probability that you survive, there is a branch in which you survive. The probability of any specific branch may be small, but the branch exists. From the first-person perspective of the observer, they always find themselves in a branch in which they survived, because in all branches where they did not survive, there is no first-person perspective to observe anything. Apply to death. Every moment, quantum events occur in your body with outcomes that could, in principle, be different in different branches. Most of these differences are irrelevant to survival, but some infinitesimally improbable quantum events could, in principle, prevent every possible cause of death. In the many worlds interpretation, these branches exist. In those branches, you are still alive. And from your first-person perspective, you can only ever find yourself in a branch where you are alive. The quantum immortality argument implies that from the first-person perspective, you cannot die. There is always a branch of the wave function where you are still alive. And since your subjective experience is always in some branch of the wave function, you will always find yourself alive. I need to be precise about the problems with this argument, because it is genuinely controversial even among physicists who accept the many worlds interpretation. The first problem is that the probability weight of the surviving branches decreases with each quantum event that could have caused death but did not. After millions of such events, the surviving branches have astronomically small probability weight. The many worlds interpretation does not clearly say that you should disregard this probability. The branches with small probability weight are real branches, but they contribute less to the total amplitude. The second problem is that the quantum immortality argument requires that there be specifically a first-person continuation, that the concept of you surviving in a branch is meaningful. In the many worlds interpretation, the branches after a quantum event each contain a copy of you. Which copy is the real you? The many worlds interpretation does not privilege any branch. After a branching event, there is no fact about which branch you are in both branches are real, and both contain observers who believe they are the continuation of the pre-branching you. The third problem is empirical. We observe that people die. If the quantum immortality argument were a significant effect, we would expect to see extraordinarily long-lived individuals who have survived against astronomical odds. We do not. The distribution of lifespans is consistent with standard biology and mortality rates, not with the selection effect that quantum immortality would produce. Despite these problems, the many worlds interpretation does say something interesting about death. In the vast majority of branches, you die at more or less the expected time. But in a measure zero set of branches, you continue to exist indefinitely, not through magic or supernatural intervention, but because of quantum fluctuations that prevented every cause of death. These branches exist in the full wave function of the universe, even if they are negligibly rare. Whether this is consoling is a matter of philosophy and temperament. The branches with extreme longevity have negligibly small probability weight. The quantum immortality argument is interesting as a thought experiment, but has little practical significance. Let me now return to the block universe and develop its implications for what death means in the most direct way. You are a world line in the four-dimensional space-time block. Your world line begins at your birth event, the space-time coordinates of the moment you came into existence, and ends at your death event. Between these two events, your world line traces a path through the block, accumulating proper time as it goes. The world line is a complete object. It does not come into existence progressively. As you live your life, the block contains the entire world line from beginning to end simultaneously. The birth event is in the block. The death event is in the block. Every event of your life is in the block. Your death event is not the end of the block. The block continues beyond your death event at later space-time coordinates, containing events that occur after you die. Your world line simply does not extend to those coordinates. Other world lines, other people, other organisms, other physical systems continue, and their world lines extend beyond your death event. But your world line, with all its events, is permanent. The block does not change. The block does not become different after your death event. The events of your life at earlier coordinates remain at those coordinates equally real after your death as during your life. The question of whether death is the end in the block universe is the question of whether the end of your world line is the end of you. The answer is, it is the end of your traversal of the block, but not the end of your presence in the block. Your world line is in the block. Your life is in the block. The experiences, perceptions, and events of your life are in the block. They will always have been. The philosopher David Lewis captured something like this with the phrase, "The world is four-dimensional and we are part of it in all our temporal extent." Your temporal extent, the span of your life from birth to death, is in the block. You are in the block at every coordinate of your world line, simultaneously in the block sense. Your death does not remove you from the block. It simply marks the last coordinate of your temporal extent. This is the most honest and most precise thing physics can say about death. You will have always existed. The events of your life are permanent features of the universe's history. Nothing, not your death, not the death of the sun, not the heat death of the universe, can retroactively remove the fact that you existed, experienced, and acted. The past is permanent. And your life is in the past of all future moments, including the moments beyond your death. The fact that your subjective experience will not continue beyond your death event is real and significant. I am not minimizing it. The cessation of your first-person perspective is a real loss, a loss of the ongoing experience of being you. The block universe does not give you immortality in the experiential sense. But the block universe does give you something that is not nothing, the permanent reality of your life. The fact that you existed, that you experienced, that you were a world line in the block, this is a permanent feature of the universe. It is inscribed in the four-dimensional structure of space-time with the same permanence as the events of the Big Bang and the events of the far future. Whether this is enough, whether this is consoling, is not a question physics can answer. It is a question about what you value and what kind of permanence matters to you. But it is what physics provides, not continued subjective experience, but the permanent reality of your existence in the structure of the universe. This is what physics says about dying. Not that there is nothing after death. The block contains events after your death event, just without you in them. Not that death is meaningless. Your world line is a permanent feature of the block, as real as the stars and the vacuum. Not that you survive in any conventional sense. The subjective continuation of your experience ends at the death event. What physics says is that the universe is a four-dimensional block in which all events are permanent. Your life is a collection of events in that block. Those events will always have been. The past does not cease to exist. It simply is, at its coordinates, forever. That is a strange kind of permanence. It is not the permanence that religions promise ongoing conscious experience in some afterlife. It is the permanence of the historical record, written not in books or memory, but in the structure of space-time itself. But it is genuine permanence, grounded in the best tested framework in the history of physics. The universe remembers everything, because the universe is a block, and nothing in a block is ever forgotten. Your life is in the block. It will always be there. And that, at minimum, is something. The 12 principles I have assembled for understanding the fabric of reality culminate in exactly this kind of engagement with the deepest questions. What does physics actually say about the nature of time, consciousness, and death? And how does the honest account compare to the popular accounts that substitute either dismissal or mysticism for genuine engagement with what the science says? Ready to change how you see the world? Get 12 principles for understanding the fabric of reality at realityprinciples.com. What does the permanence of the past in the block universe mean to you when you think about death? Tell me in the comments. If this changed how you think about what physics says about dying, about the permanence of the past in the block universe, about the conservation of atoms and information, about what the many worlds interpretation implies for personal identity and survival, tell me in the comments. Tell me whether the block universe's promise of permanent reality for the events of your life is consoling, and why or why not. Tell me whether the conservation of atoms and information provides anything that feels meaningful to you, or whether only the continuation of subjective experience would be enough. And subscribe if you want to keep going into the places where physics meets the deepest questions about existence, consciousness, and what it means to be alive in a universe governed by the laws of physics.